Let's start today's demo. First, open a browser and navigate to aibmt.com. Today, we will conduct a demo on a Windows OS. This version is not the previous version that uses the MinGW compiler for C++. Instead, it's a modified version that uses MS-Vis compiler. The reason for adopting the MS-Vis compiler is that most libraries provided for Windows, such as OpenCV or ONNX runtime, are compiled as MS-Vis binaries. By making this change, it has become much easier to integrate third-party libraries in a Windows environment compared to the previous setup. In this project, you will find the predefined settings, which include sections that should not be modified and others that can be modified. To run the provided classification example codes, the project includes the necessary third-party libraries like OpenCV and ONNX runtime. First, let's clone the project from the given Git address. After cloning, if you run the project, you will have an environment set up to evaluate the classification task using the less than 50 ONNX model and the dataset we provide. Since the model needs to be loaded, let's define the model's path. I run the program in release mode instead of debug mode. And we will use the model in release model classification folder. And I will change this path like this. The interface has been slightly modified. Looking at the interface, you will see an optional section where you can provide additional data for database uploads. This optional data allows the user to input CPU type and accelerator type, which can then be stored in the private database. The mandatory sections to implement are initialize, convert to data, and run inference methods. I've already explained these two methods before. The convert to data method takes an image path, loads the image, and converts it into one of the defined types in variant type. As for initialize, it's used for initialization instead of placing the logic directly in the class constructor. This allows validation to occur in the app before initialize method is called. If a user makes a mistake at initialize method, the app can catch it and displays another message. Therefore, an initialization logic is recommended to be implemented in the initialize method. In the reference implementation, initialize is implemented in the get optional data method. Since I'm running the ONNX model on the CPU, I will set accelerator type no accelerator. In convert to data, the image path is taken and pre-process it to match the trained model. And converted it into a supported type such as vector floats. This vector float is supported by variant type, which is why it can be used in this way. If a type is not supported by variant type, for example, vector string, a compilation error will occur. Therefore, we will convert the data into one of the predefined types and pass the image in the form of a vector float. Once the data is prepared, it's loaded into RAM. The batch size is determined based on the scenario, and the batch data is preprocessed accordingly. The results of the inference are stored in a structure called BMT result. For classification tasks, BMT result includes the predicted class index, which is crucial for calculating accuracy. After obtaining the BMT result is stored and returned as vector BMT result from non-inference method. The app then calculates accuracy and uploads the performance result to the private database. Now let's build the project and run the generated program. When executed, the app runs based on the interface that was just implemented. Before running the BMT, you need to log in to bind your account to the database, allowing the performance result to be uploaded. It seems the specified model path from the code doesn't exist. Let's navigate to Form's data download page to download the less than 50 V2 ONNX model. Once downloaded, the model will appear in the model classification folder. Now that the model is ready, let's proceed. However, since the dataset is also missing, we need to download it. Download automatically, click Yes to start the download. If you click No, you will need to download it manually like this. For now, I will click Yes and the dataset will be downloaded automatically. Once the download is complete, the dataset zip file needs to be extracted. You can monitor the extraction process here. I've noticed that extraction is significantly faster in Linux compared to Windows. Windows extraction tends to take a far longer time. Once the extraction is complete, 50,000 images and label data will be ready. The app uses the label data and image paths to load the data, run the submeters implementation for inference, and compare the result with the labels to calculate accuracy. Now that everything is ready, navigate to Form's main page and click the Start BMT button. With the model and dataset prepared, there should be no errors anymore. The app will preprocess all 50,000 images. Once preprocessing is complete, inference begins. The progress and performance result can be monitored through the log screen. Once complete, the final result will be displayed and be uploaded to the private database. You can confirm that the data in the private database matches what's displayed in the log screen. Additionally, you can also check the uploaded result directly in the WASP private database. That concludes today's demo. Thank you.